Okay, so part 2 of lesson 3 is where we look at configuring VLANs. Now there are in fact several things we need to do here, but I'd like to break up this video into 3 main objectives. Objective 1, we create the VLANs on switch 2, switch 1 and switch 3. We create 5 VLANs. Okay, we create a VLAN 10 with the name faculty. We create VLAN 20 with the name student. We create VLAN 30 with the name guest. And we create 2 additional VLANs, VLAN 99, which will be the native VLAN, and VLAN 40 for management. Okay, so at the end of objective 1, we should end up with 5 VLANs in switch 2, switch 1 and switch 3. Objective number 2 is we start assigning ports to each VLAN. Now we will only be focusing on VLAN 10, 20 and 30. Okay, so we're going to assign a range of ports, and this is the range of ports we're going to be using. Port range 1 up to 7 will give it to VLAN 10. Okay, so this PC connected to VLAN 10 is connected to VLAN 1. Okay, and so is this machine here. It's connected to port number 1. So we'll do the same for switch 2 and switch 3. You remember by default all interfaces are part of the default VLAN, VLAN 1. So we need to take them out of VLAN 1 and assign them to each respective VLAN. So port 18 to 15 will be for VLAN 20, port 16 to 20 will be for VLAN 30. And so we'll do the same on switch 2 and switch 3, except for switch 1. We will not do that on switch 1. Objective number 3 is we start configuring trunk links. Okay, so to allow for VLAN 10 PC to communicate with VLAN 10 PC on a different switch, we need to ensure that there is trunking here. There is also trunking configured here. Okay, so we'll configure 2 trunk links, one between switch 2 and switch 1, one between switch 1 and switch 3. Okay, so let's begin off with the first task, which is to create the VLANs. Okay, so you will notice I haven't configured any basic settings. You can do that. What I'll do is I'll just configure host name. Okay, switch 1 or switch 2, and I'll leave it as that. I'll just keep all the other basic settings and go straight into objective 1, create the VLANs. Okay, so we need to create VLAN 10 and give it a name faculty. Again, if you don't give a name, the system iOS will automatically create a name. VLAN 10, VLAN ID will be, or name will be 00010. Okay, here we need to give a name. VLAN 10, VLAN 20, name will be student. Okay, VLAN 30, name is going to be guest. Then VLAN 99, name will be native. And VLAN 40, name is going to be management. Okay, so when I exit or end this and I go show VLAN brief, I should be able to see, apart from the default VLAN 1 and 102 all the way to 105, which I remember for legacy networks, I have VLAN 10, 20, 30, 40 and 99. Okay, so I have 5 additional VLANs that have been created. Okay, so what I'd like you to do is, that's objective 1. You pause the video, you go to switch 1, you go to switch 3, you do the same. Create the same 5 VLANs with the same names on switch 1, same 5 VLANs with the same VLAN IDs in switch 3. Okay, so you do the same thing on these 2 switches. Pause the video, do that, and then we'll continue on. Okay, so I'm assuming that you have paused the video, you have done all that. If you go to switch 1, you do a show VLAN brief, you should be able to observe the same thing. You'll see that interfaces, VLANs have been created. Okay, 10, 20, 30, 40, 99. So it will be the same, should be the same on switch 3. Okay, so after we've completed creating the VLANs, the next thing to do is port assignment. Okay, VLAN port assignment. And remember, we are going to assign a range of interfaces to these three VLANs, 10, 20, 30. So we would want that port 1 up to 7, whenever you connect a PC to any one of those ports, they will become part of VLAN 10. So as 8 to 15 for VLAN 20, 16 to 20 for VLAN 30. Okay, so we'll do that on switch 2, and again you pause the video, you go to switch 3 and apply the same. You won't do that in switch 1 but switch 3. Okay, so this is what we do. We go to VLAN, we go to switch 2, conf t int range fa01 all the way up to, okay, what was it again, 7. Switch port, we're going to force the switch port mode to access port, and then switch port switch port access VLAN. We'll make this part of VLAN 10. Okay, by the way, while I'm doing this, you may notice I keep getting this message, CDP for native VLAN mismatch discovered here. It's because prior to this video I've gone ahead and I've configured the settings in S1 and S3. I've configured the VLANs for the trunk interfaces. That's why you see it keeps giving me this message. Okay, maybe not for your case, but when that happens, remember, trunk links, they would want to have the same native VLANs. Okay, so it keeps giving me this message. The discovery protocol, CDP, Cisco Discovery Protocol, keeps sending that message. Okay, so next range, int range fa0/8 to 16. Okay, and oops, it should be not 8 to 16, int range fa0/8 to 15. Okay, switch port mode access and switch port access VLAN 20. Okay, exit int range fa0/16 the way up to 20. Switch port mode is access port, and switch port access VLAN 30. Okay, so if I end this and I do a show VLAN brief, you should see that now these interfaces are now part of VLAN 10. See, 1 to 7, and then the next VLAN has port 8 up to 15, 30 has port 16 up to 20. So we remove them from the default VLAN 1, place them under each of those three VLANs. The rest of the interfaces are still part of VLAN 1. Now you'll notice something here. I have gone ahead and configured interface port 24 as a trunk interface. That is why you'll see 21 is here, 22, 23, 24 is missing. Okay, 24 is missing because I've configured the 24 already as a trunk interface. So if I do a show int fa0/24 switch port, you can see that operational mode has been set to trunk already. Okay, so how did we do that? Okay, so again, the configs are there. You go int fa0/24 switch port mode trunk. Notice we are forcing it to trunk. The next thing we need to do is switch port trunk native VLAN 99. Okay, and notice that the message that popped up earlier on, mismatch, now it's been restored. Okay, because now they are on the same, they have the same information about who is the native VLAN here. Okay, so switch port mode trunk, switch port trunk native VLAN, and we need to allow switch port trunk allowed VLAN. We need to allow 10, 20, 30 and 40. Okay, on this trunk interface. So we are telling this trunk interface allow all this traffic. Okay, so we leave out VLAN 99. Okay, so Once that's done, exit, make sure to save for WR or copy run start, and then you repeat the same command in switch 1. Okay, so you go to switch 1's port 24 int fa0/24. You need to make it a trunk interface, so switch port mode trunk, and then switch port trunk native VLAN 99, switch port trunk allowed VLAN. We need to allow VLAN 10, 20, 30, 40. Okay, and that there. Now you will notice port 23 should also be a trunk interface. Okay, it's connected to switch 3. Okay, so we need to do that. So conft int fa0/23 switch port mode trunk, switch port trunk, set the native VLAN to 99, switch port trunk allow. Okay, allow VLAN 10, 20, 30, 40. Okay, end it there, save that, go to switch 3, and we'll basically do the same here. Okay, so conft again, make sure you go to the correct interface, port 23, switch port mode trunk, switch port trunk native VLAN 99, then switch port trunk allowed VLAN 10, 20, 30, 40. Okay, oops, forgot. Okay, so once that's done, just make sure you verify that PC0 has an IP address that belongs to subnet 10. You'll realize that each VLAN is also in a different subnet. This is subnet 10.0, this is 20.0, 30.0. Okay, so make sure IP addresses are assigned in each of the subnets, and then you can do a test ping. Okay, so I'm going to ping from PC0. We'll try and ping 172.17.10.11, which is PC3 on this end. Okay, so reply should be successful. Again, remember, reply is successful because of the fact that we've created the trunk interfaces. So data is forwarded, traffic is forwarded from here across the trunk interface to here. Okay, so notice that broadcast messages will remain within VLAN 10. For 20, it will remain within 20. 30, it will remain within 30. Okay, so that's intra-VLAN communication, and that's a straightforward configuration of VLANs. Create the VLAN, assign interfaces to the VLAN, configure the trunk interfaces. So trunking is required when you have VLANs in multiple switches. Okay, so again, point you have to take note of here is that 10 and 20 are not going to see each other. So as 20 and 30. Only VLANs, PCs in the same VLAN should be able to see each other. The next module on VLAN, inter-VLAN communication in module 4, that's where we configure routing functionality or layer 3 functionality to allow for inter-VLAN communication to happen. At this stage, only PCs within the same VLAN are able to see each other. Now, one more thing, if you look at the lecture notes towards the end, you'll see something called DTP, Dynamic Trunking Protocol. The Dynamic Trunking Protocol is a Cisco proprietary protocol, meaning it's only for Cisco devices, and that protocol allows for interfaces to automatically negotiate. Okay, so this is what it means. If you go to switch 2 and you do a show int fa0/24 switch port, you will see that the switch port F024 administrative mode has been forced to trunk. Okay, operational mode has been forced to trunk. Now we can set it to automatically negotiate. Okay, automatically negotiate without manually forcing it to trunk. Okay, this is what I mean. If you go conft int fa024 Okay, switch port mode. Okay, just leave a space, put question mark. Can you see that we have access, dynamic and trunk? You remember what we did earlier on? We configured the range of interfaces and we forced the interface from dynamic auto, we set it to access interface. Okay, so it became an access port. And then we went to port 24 and we set switch port mode trunk. So we manually set trunking mode to that interface. It was on dynamic auto, so we can set it back to dynamic auto, dynamic, and then leave a space, put question mark. Notice there are two options there, auto and desirable. Now look at the nodes and you will see that when it's set to dynamic auto, it will set the trunking mode dynamic negotiation to auto. And what it's going to do here is let's go auto question mark. Okay, notice we setting it to auto. It will try to negotiate with the other end of the link. Okay, so what I'm saying here is if this is set to auto, okay, let's say we set it to dynamic auto, it's supposed to negotiate. Okay, this interface is supposed to negotiate with the other end here. Remember, it's a point-to-point link. Okay, so it's supposed to negotiate with port 24 on switch 1. Okay, so let's go ahead and set it to switch port mode dynamic auto. Okay, now when we set it to dynamic auto, let's go ahead and end it and type show int fa0/24. Oops, forgot something. Switch port. Okay, if you type show int fa0/24 switch port, you'll see that the operational mode, admin mode, is set to dynamic auto, but operational mode has been forced or has been negotiated to trunk. Okay, you get what I mean here? Admin mode is set to dynamic auto, so it's kind of telling the interface you negotiate. If the other end is a trunk interface, well, you set yourself also as a trunk interface. So did you see that? Because the other end here, this end is a trunk interface, this end is dynamic auto, it negotiated and set itself to trunk also. Okay, now let's go ahead and configure this interface. Okay, now why is that important? Well, you don't have to configure this as dynamic auto. By default, it's dynamic auto. Okay, it's set to auto, which means that as long as you set this to a trunk, this should negotiate and also set itself to trunk as well. Okay, and that saves you from having to configure all the time. Okay, now again, this is only between Cisco to Cisco devices. Well, if I set this to from dynamic auto, let's go back, conti int fa0/24 switch port mode. Okay, we go dynamic, and then notice dynamic, I have auto and desirable. Okay, so let's set it to desirable. Okay, so desirable. Now let's see what happens here. If we set it to desirable, from dynamic auto to dynamic desirable, let's check out the show int fa0/24 switch port. Okay, when it's desirable, what happens here is that the administrative mode is now desirable, operation mode is still set to trunk. Okay, so it's desirable because the other end is trunk, it's also a trunk. Okay, it's also a trunk. Now if I go over here to switch 1 and I go int fa0/24 and then I type switch port mode dynamic switch port mode access. Okay, notice now there'll be a problem there. Okay, I forced it to access, so access with dynamic desirable will not work. Okay, how about switch port mode dynamic auto. Okay, notice with dynamic auto it's saying command rejected, conflict between non-negotiate and dynamic status. Okay, so one cannot be auto and one cannot be desirable. Okay, let me change that. Switch port mode dynamic desirable. Okay, again notice non-negotiate. Okay, because remember we forced it to access. Okay, so switch port mode dynamic, switch port mode, let's set it to trunk. We set it to trunk interface, it negotiates, changes the state to up again. Okay, let's go switch port mode dynamic auto. Okay, again command rejected because this one is dynamic negotiate. We sent it to desirable. Okay, so what you are really seeing here is the best way to do this is when you are trying to make sense of that part, you go back to section 3.5 of the lesson notes and you'll see this. Okay, you see access. You'll notice when we set it to access, it's a permanent access mode and it will negotiate to convert the other end of the link into an access link. If it's set to trunk, it's permanent trunking mode and it will negotiate to convert the other end to trunk. If it's set to dynamic auto, the first thing we did, it will become a trunk interface if the neighboring interface is also set to trunk or desirable mode. Okay. However, if you set it to desirable mode, it will actively seek to become a trunk by negotiating with either auto or desirable interfaces. Okay, so when you look at the next slide, you will notice it's because trunk interfaces are point to point. If you compare one end is let's say switch 2 is dynamic and switch 1, both ends, one is dynamic, it will become an access link. If it's desirable, dynamic desirable and dynamic auto, it becomes a trunk link, a trunk interface, okay, or a trunk link, and so on. Okay, so this is the comparison, and it's all to do with the protocol itself. Okay, the protocol negotiates through the CDP messages and it allows to do that. Okay, so that's basically it. I hope when you're doing this, looking at this video lesson, you make reference, because I'm making reference back to the lecture notes. You have the lecture notes open, so you can go through with both the video and the lecture notes side by side, so you make sense of what's covered in the lessons. So DTP is an important tool, protocol for Cisco, but it may not work for non-Cisco devices. Okay, it will not work because it's a Cisco proprietary. Okay, so once again, that's the end of lesson 3. We've created the VLANs, we've assigned port interfaces to VLANs, we've created the trunk interfaces, and we were able to observe how the DTP protocol, through the use of the auto and static and dynamic auto and desirable, are able to negotiate or not negotiate whether they should establish trunk interfaces or not. Okay, so that brings me to the end of lesson 3. In lesson 4, when we cover module 4, we will look at how do we allow for VLAN 10 and 20 to communicate. Okay, that's inter-VLAN communication to happen. So we'll do that next week in our next lesson.